When a pump does not run properly, we must find what is wrong and fix it, a procedure often called troubleshooting. Before you can find what is wrong, you must be aware that something is wrong. You must recognize an unusual condition. You can recognize some unusual conditions by what you can see. A discharge gauge registering lower than normal pressure, for example. You can hear some unusual conditions, like the rattling sound a centrifugal pump makes when its suction is starved and it is cavitating, or the sound of a short stroking reciprocating pump. Some unusual conditions are detectable by feel. An obvious example is an overheated bearing. There are even situations where your sense of smell will tell you about an unusual condition. A hydrocarbon leak, for example. An alert operator must recognize unusual conditions. But recognition that something is wrong is not enough. The operator must find what is wrong. To clarify, a gradually lowered pumping rate is an unusual condition. What is wrong may be, among many possible reasons, a suction strainer that needs cleaning. Fix it in your local situation may mean fixing it yourself in some cases, issuing a work order in others, and in still others, reporting it to your chief operator or supervisor so he can issue a work order. Now let's do some troubleshooting on steam-driven reciprocating pumps first. Let's look at a pump whose capacity has gradually decreased. Before we can fix it, we must find why it no longer pumps as much as it used to. One possibility is that the bypass circulation line valve is leaking. Here it is. Now, how can we check to see whether it is leaking? This particular pump is pumping warm oil, about 130 degrees Fahrenheit. If the bypass valve is leaking very much, the temperatures upstream and downstream of the valve will be about equal. Feel the underside of the line, not the top where the sun strikes, both upstream and downstream of the valve. In this case, suppose the temperatures are definitely different. Then this valve is not leaking very much. Maybe the pump packing is leaking. This is easy to check. We need only to look at it. Not on the liquid end. Leakage here is just about what it should be to lubricate the packing. The steam end is okay too. If liquid end or steam end packing were leaking excessively, we would have to tighten a gland or replace packing. Lower than normal steam pressure also reduces pump capacity. We would probably know already if steam pressure had dropped, but let's check. No, 120 psi, just about what it should be. Lower suction head reduces pump capacity. Let's check the gauge on the suction line. 6 psi. Well, it's often that low, sometimes lower. Let's calculate what it should be. We're pumping kerosene, specific gravity 0.8. And there's about 20 feet in the tank we're pumping from. 20 times 0.8 times 0.433 is about 6.6. That checks. And it also indicates that the suction line strainer isn't badly plugged. We won't have to clean it right now. Now let's check out the discharge system. Let's walk the discharge line and see if any valves are partly closed. No, they're all wide open. If our pump's discharge pressure is normal, we ought to have a good pumping rate. Let's make some calculations. Steam pressure is 120 psig. This is a 12 by 10 by 18 pump. 120 times 12 squared over 10 squared equals about 173 psig. The pump discharge pressure just can't be that high. If it were, the pumping rate would be high. Right. Discharge pressure is only 85 pounds. No wonder we aren't pumping much. Well, we'll just have to stop this pump. We'll probably find some badly worn or broken valves. Valves that do not seat properly allow internal pump leakage and lower efficiency and capacity. Worn pump parts, especially valves, are the most common cause of loss of capacity in reciprocating pumps. You may think we did a lot of checking to find out what was wrong with our reciprocating pump earlier. That's right, we did. An experienced pump operator would probably find the trouble much more quickly. Let's see how he might work with another pump. It too has lost capacity, but suddenly, not gradually. Possible causes are about the same as for the first pump: bypass leaking, packing leaking, steam pressure low, low suction head, high back pressure, worn or broken parts, especially valves. The operator can eliminate most of these possible causes just by alert observation on the daily rounds. In this case, let's suppose that the suction pressure is considerably lower than normal. The operator knows this from previous observations of normal suction pressure. Yet, as he knows, he's pumping from a tank with a high level. The operator suspects an obstruction in the suction line. If suction valves are all wide open, this strainer is likely to be plugged. The operator cleans the strainer, and the pump capacity returns to normal. So far, we've emphasized looking for the cause of pumping troubles. Listening is about as important as looking. Usually, you can tell by sound when a reciprocating pump has lost prime. The pump is likely to overspeed, stroke very rapidly, and the resulting clanking can be heard for some distance. Losing prime means that liquid no longer fills the pump cylinders. There are several possible causes. One is low liquid level in the tank or tower. A low liquid level in the tank or tower may allow a large amount of air to be sucked in on each suction stroke. Air takes up cylinder space that should be occupied by liquid. An obstruction in the suction line can cause loss of prime. As we've already seen, the obstruction may be a plugged strainer. To restore prime, slow the pump down by throttling the valve in the steam line. When prime has been lost because of low suction liquid level, this may be the only step necessary. Or you may have to stop the pump, close the discharge valve, and bleed off air and vapor from the pump. Correct causes of loss of prime as soon as possible. At first, troubleshooting may be difficult, but as you gain experience, it becomes easier. Keep at it. Finding and correcting pumping problems makes your job easier and more satisfying. Now turn to workbook number 2 and complete exercise 20.